Hi everybody, welcome to this presentation. My name is Stephane Begaudeau, I'm working at Obeo and I'm here with Pierre-Charles David from the Sirius team too. And today we are going to talk about our work to bring Eclipse Sirius into the cloud. So Obeo is a key player in the Eclipse modeling ecosystem. We've been involved in several open source projects in the Eclipse Foundation, starting with a project like Sirius and Axeleo. We've also contributed to GMF, eCore Tools, and EMF Compare. And we've built over the year a long experience in developing graphical toolings. And now we will leverage all of this experience to bring our tools into the web. It's more than just drawing nodes and edges. It's also about providing a full-fledged development environment to create graphical modelers. So for that, we have been working on two different directions. First of all, we are still building new features for those who are using Sirius today for the future release in the months to come. But we are also thinking about the fundamentals of Sirius to build the platform of the future.
So as you will see in the rest of the talk, we have started some very ambitious plans for the future of Sirius, but these are for the medium to long term. And in the meantime, we'll continue to release new features in the upcoming versions for the existing users. So Sirius is a major framework, but we continue. I'll give you a tour of the few of the features we've added this year in Sirius 6.0, which was released in June with Photon, and 6.1, which was released just last Friday. So one of these is support for configurable background color on diagrams. This is a feature that can be configured by the specifier, the person who creates the modelers, not the end user. So here on the example, it's a fixed color, but like everything in Sirius, it can be actually computed from an arbitrary expression, and it is fully dynamic and can represent anything computed from the state of your application. We've also added a new tool which comes for free for all Sirius diagram. It's available here on the palette, the small icon. We call it the magic edge creation tool because before, when you had in a Sirius modeler, you have different kinds of edge creation tools. They were sometimes hard to find in the palette. Now you can have a single tool which covers all the cases. You just have to select it, click on the source and target element, and Sirius will automatically find all the applicable, all the compatible tools and propose them to you if there are several ones. If you've created actual modelers which are not just toy examples, you've probably had to complete the design file with some Java code. It's very easy to do in Sirius, but these were two different worlds, not really well connected before that. So in Sirius 6.0, we've added the possibility to quickly navigate when you are inside the design file. If you are in expression which goes into some Java code you wrote, you just hit F3 and you can open directly the Java code which will be called at runtime at this point. Still in 6.0, we've added a new kind of nodes available here on the palette that can serve as hyperlink between different representations. So you just create it on the diagram like a normal node, but you're asked for a target representation, like here on the dialog. And when you select it, you can also complete the node with some text. And after that, the node behaves like a hyperlink to quickly navigate between create a navigation links between your modelers. Sirius has always supported automatic layout of its diagrams, but it was using a generic algorithm inherited from GMF, which does the job, but is not customizable, and in some cases, it's not very well adapted. So in 6.0, we've added experimental integration with the ELK framework. It's an official Eclipse project which offers a large panel of very high quality layout algorithms for diagrams, and now you can leverage this directly in Sirius. I'll show you a quick video about that. So here we'll create I think we can go higher. Here. So we'll create an initial diagram, and we'll use the default layout algorithm, which in this case does a good enough job, but it's not configurable at all. So now when you open the definition of the diagram, you have a new capability to try different algorithms coming from ELK. So you just select new layout. Here you see all the different algorithm families supported by ELK, and you can test live the result of your algorithm. ELK exposes a large set of configurable parameters for each of its algorithms, and you can customize them directly in the Sirius configuration file like this. Here we change the direction of the layout and some spacing factor. And as soon as the specifier saves the definition, you can try and see the result directly. So it's very easy for the specifier to quickly iterate and find the best combination that matches a particular kind of diagrams. We have tables in Sirius. I don't know how many of you uses them, but they can be quite useful. Because they support sublines, tree-like hierarchy of lines, we've always added the gray header on the left side here, which is needed in these cases. But when you have a very simple table, it can be a little bit ugly. So we have added the possibility to hide it, and then in simple cases, you have really clean tabular representations. You can also in Sirius contribute to the context menu of your diagrams, but until 6.1, all your contributions were added at the top level of the menu. Now you can group them, and you can even contribute your custom operations inside existing menus if you know the technical ID corresponding to this section. As a special case, we've also added the capability to contribute directly into the select combo here, which is available on diagrams. By default, it supports select all, select connection, select shapes. And now with this new capability, you can create really interesting kinds of selection tools customized for your domain. Here we have examples, for example, to select all elements on a diagram which correspond to a given semantic type, or even for power users, you can allow them to enter complex expressions and select on the diagram for further processing all the elements that matches this expression. Sirius also supports the capability to hide individually any element on a diagram. Here. Hiding an element is quite easy because you just select it. Okay. And it, Wi-Fi issue? No, okay. You can, to hide an element on the diagram, it's really easy. You just select it and hit Ctrl-H or go to the context menu. But once it's hidden, well, we had a UI to select which elements to reveal again, but it was really cumbersome to use. So now we've added a new capability, a new mode. Sorry, I'm going back here. A new mode here, which can be enabled, and when you are in this mode, all the elements on the diagram, even if they are normally hidden, appear in transparency, and you can simply double-click on any node, edge, or even label to switch, to toggle their visibility, and once you're okay with the result, you can go back to the normal mode and see the result. So all of this is available right now. We've just released Sirius 6.1 last Friday. It's available on the Eclipse website. You can go to the wiki to get the actual details about the update site. And this is also included in the Obeo Designer Community Edition 11.1.0, which has been released on Monday, I believe. So it's ready to use right now. Obeo Designer Community Edition is a free package which contains only open source software. It's a packaging of Sirius, which everything you need to get started using it. No need to go and try to install some stuff from update site at Eclipse.
So as we've said it before, we are also working on the future of modeling tools. And for that, we've been running a live survey at EclipseCon France on June, to gather some feedback from the community about what you wanted for the future of Sirius, for example. So you can see here some results showing that the community would like to see Sirius being integrated in web application, but also in Theia and Che, for example. We also asked for keyword about what you wanted for this integration. So you can see the cloud of the result here, and the kind of features that were expected, especially for the first versions of those new tools. So here you can see what Sirius is today as a desktop application. You still have your diagram with the palette on the right, and you can have a properties view allowing you to edit all the details of the selected elements. So while it is nice, it comes also with some constraints because all the designers based on Sirius are desktop applications, so you have to install them, and for large customers who have to deploy the same version of their tooling for all their users, it's a bit painful to do, and updates are also a bit cumbersome in such situation. You need to prepare for the storage and so on. So we've been working on bringing Sirius as a web application, and you would be able in such situation to retrieve everything you have used in Sirius today. So your diagrams, but also the palette with all the tools that you have defined. So for that, we want to base this new version of Sirius on web technologies so that your designers will become cloud application. You won't need to install anything, and upgrades will be very smooth to do for your users. The diagrams will be able to be manipulated from various devices, and it will also be easier to adapt to large increase in workflow. But we also want to continue to carry the spirit of Sirius with us. So for that, you will be able to define your modeling workbench just like in Sirius today. It will be completely dynamic, no code generation involved. It would leverage all the existing interpreter, for example, EQL. You would be able to reuse Java services, and it will allow you to have a development environment to create your diagrams, which is very flexible and which allows you to create designers even for complex situations, but this time rendered in a browser. So today we will show you first look at some of the prototypes that we have built.
So we're going in this direction step by step, and the first one we chose is to introduce some web technologies directly into the existing Eclipse runtime RCP application. We chose this direction because it makes it easier to go incrementally into this new kind of technologies, and using web technologies can also be useful to create right now complex UIs that can be really difficult to create using legacy APIs like SWT or JFace. Additionally, it means that what we are building right now, and I will show you, is usable even for most of our users who are still looking for something which runs inside Eclipse for the time being. So the two worlds are not incompatible. So everything we've been built on this first step is based on a web component library, which is open source and available at this location. It's based on it defines a set of React components. React is a really nice JavaScript library which can be used to create dynamic UIs. And using this library, we can combine all the different components to create more complex applications. Like here, for example, on the left, a dashboard, which using different kind of cards can give an overview of the metadata about what's installed inside the Eclipse server running behind, and all the projects available. And all these web components can be available right now directly inside Eclipse using an embedded web browser. So here we have a completely standard Eclipse which uses inside the Sirius editor an additional tab here, which we call workflow as an example application. And inside this, this is not inside this tab of the editor. It's an embedded web browser which uses communicates with the server. Sorry, the Sirius HTTP backend to display web components. So we've used this technology to create what we call a workflow editor, which is an experimental feature we've introduced in 6.0. It's a kind of new dialect for Sirius, which already supports diagram, tables, trees, and property views, and now we've added workflow. So the idea here is that you still have a Sirius specification, but you have new capabilities to define actions that top-level actions that the user can trigger on their modeling project, and these actions are organized into pages. This is similar to the Activity Explorer, some of you may know from Capella, for example. Except the UI is different, and here you can see the result. We have here inside the Sirius specification, we have defined the different pages, and you get the result as a nice web page directly inside Eclipse. So here we show how it works in practice. It really follows the same principles as anything in Sirius. It's very dynamic to create. So here we have a UML modeling project. I'll open the Sirius editor on the corresponding session, and here we see we have a new tab appearing which shows some high-level metadata about the project and the workflow containing different actions configured by the specifier for this kind of project. And these are defined like anything else in Sirius directly inside the ODesign file. Here we can see we can retrieve the different capture, review, and help pages, etc. And the actions behind the hyperlink here in the browser are actually defined like anything else in Sirius using the same dialect. So you can create open representations, code into Sirius code, or even any arbitrary Java code. For example, here we use some Java service to open a browser and report an issue on the modeler. So this was the first step. The second one is to make Sirius independent from the Eclipse platform. And by this we mean progressively modularize the Sirius code base to make it more and more of it available deployable on the server side. This means isolating all the dependency we currently have on particular technologies. Currently we depend obviously on the Eclipse UI, on GMF runtime for the diagrams, on the Eclipse workspace for the storage, and of course on the Eclipse runtime. So the idea is that we don't want to create two different versions of Sirius, but refactor the existing one to to modularize the existing code and push as much as possible of it, all the code that we've created for more than 10 years now. We don't want to lose it, but we want to make it more independent on particular technologies. And on top of this, we build both one version which will be embeddable on the server side and available through HTTP, and one which will continue to work on a classical Eclipse RCP context. So all of this will be contributed, all of this work on the new architecture will be contributed as usual for us as open source in the Eclipse Sirius project, and we'll continue to maintain the Eclipse community and contribute to the release train. And as is the case today, it's possible that some of the extensions that will be added to this new model will stay proprietary. Currently, we have a community edition of Sirius, of Obeo Designer, which is a full experience, but only open source components. And for large-scale deployments in enterprise, we have some added functionalities which are proprietary in our team edition, and probably the idea will be the same. So here a quick demo. No, I think I have actually a demo for this. So here we see, I've opened a new tab in my browser. I'm not cheating, it's a browser. And here we see we have an initial project, so I can click on it, and we can see the same kind of UI, but this time running, there is a Sirius headless server running in the background, and I can get the same kind of UI. I can find the same workflow here. So here we have no semantic resources, so no actual domain model in this project, but we have created an action to create a new one. It's empty initially. We have another action to fully fill it with some initial data, and then a final one to create a diagram. This is using the plain Sirius API on the server side and rendering the result on the web page. And I can open the diagram, and this is a Sirius diagram, which is interpreted from the classical O-design file. It's exactly the same that we used for basic family tutorial, but this time rendered on the web.
So in order to bring these features into a web browser, we have also worked on our HTTP API in order to expose some capabilities from Sirius to the web. So here you have the architecture of Sirius as a desktop application, which you should be pretty much familiar with. So Sirius reusing GEF and GMF, and you can build your modeling tools on top of this. And this is the actual architecture of the web version of Sirius. So we are still reusing some core components from Sirius. For example, everything used to compute the diagrams, everything used to handle viewpoints, the Axeleo query language interpreter. We're also reusing some components from Eclipse, like EMF, of course. And on top of all that, we have built our HTTP API thanks to GraphQL and the Java implementation of GraphQL, and we are exposing those features thanks to HTTP and WebSocket, along with other capabilities like the manipulation of diagrams thanks to our WebSocket API. So with GraphQL, it allows our user to ask exactly what they need from our HTTP API, and they will receive just that. It also allows us to aggregate multiple services in one endpoint. So right now we have services to retrieve information from the workspace, the available projects, the folders and files that are inside of those projects. We can also retrieve some information from EMF, like the states of the package registry. And we're also providing information from Sirius, the activated viewpoints or representations available. You can create new representations thanks to the HTTP API. We are also experimenting with GraphQL subscription. It's a concept which allows you to register a query which will be executed for some specific events. So if you want to know more about this GraphQL API, we will have a talk specifically for our HTTP API this afternoon. Here you can see an example of a query using our GraphQL API. So we are starting by requesting a project, then a specific resource in the project. From this resource, we are asking for all the representation available on this resource, and then we are asking EMF about some concept of that are used inside of the diagram. So you can see that we can navigate in all the concepts manipulated by the server quite easily, but more about that this afternoon. So we are moving with this step by step, and one of our first milestones that we wanted to achieve was being able to render Sirius diagrams inside of a web browser. So for that, we want to leverage the power of Sirius and all the existing features that we have built over the year. So for example, in this small video, we are showing side by side the O-design file with the definition of the diagram that you are used to and the web rendering of the diagram, and we can iterate just like in the desktop application in order to build our graphical representation. We can change, for example, the color of the edges, and the web browser will be refreshed automatically. We could create new tools and they would appear in the palette, and we can this way build very efficiently our graphical modeler. So this work is based on Eclipse Sprotty, which is a small JavaScript library used to build graphical representation. It's an open source project which is now included in the Eclipse Foundation, and it works very nicely with Eclipse ELK that we are also using for our automatic layout, like we showed before. And all this is also based on other mainstream technologies such as React or Jetty. We are also supporting other features, for example, layers that you have defined in your Sirius diagram, which once activated or deactivated will change the state of the palette and of course change the state of the diagram. And you can see the automatic layout which recomputes the appearance of the diagram. We have also added support for tools in the palette. So here you can see a first version where the tools are retrieved from the server, and we are using all the expressions and Java services that have been defined before in our BPMN designer in the web page, just like before.
So this was Sirius on the web integrated as a plain application, but we are also looking for integration inside the current generation of cloud IDEs, notably Theia and Che. So here a quick demo, this time, of the integration in Theia. So here we have the, oh, it's already running, sorry. Here we have Theia running. We've added here on the left an extension built on top of the Theia APIs, which contributes a new panel here and a new palette on the right. And here it's connected to the same Sirius server we used on the earlier demo, but this time it's integrated inside the Theia UI, and we have the same modeler running from the same server with exactly the same capabilities, but integrated inside the Theia UI. And finally, the next step is to integrate Theia inside. Sorry. So this is Eclipse Che, which uses Theia in its new generation for its UI. Here we are asking Che to provision a Theia Sirius workspace. So it's deploying containers inside in the background, and you will see this time inside Che we have Theia running with our Sirius extension, the same I demoed earlier, and everything works perfectly fine. So we can here inspect the workspace and open the Sirius diagram. We can have access to the same palette with all the tools and layers correspondingly. So this is an overview of the timeline of our work on all these areas. So on the left, we corresponds to the beginning of 2018, where we started 2 experiments in parallel. So in blue, we have the workflow DSL that I showed earlier, which was the first step to integrate Eclipse web technology, inside Eclipse, and start to build on an Eclipse Sirius server to render the HTML pages, but rendered inside Eclipse. And in parallel, we started the experiments on the GraphQL APIs and more powerful HTTP services. This was built completed with web-based diagram experiments. So in 6.0, for Photon, we released an experimental version of workflows that you can install and try and use it and give us feedback. And this, and in parallel, the experiments with the web-based diagram showed, well, it allowed us to identify the first pain point in the current Sirius architecture where we need to be more modular. So we started in green different small step efforts to start modularize the core of Sirius for the needs of these various experiments. And the idea is to continue this way. We will probably release a workflow, stabilized version of the workflow by the end of the year or maybe early 2019, and continue the various experiments on the diagram side. And as soon as we have elements that are deemed stable enough, they will be integrated back into the main line. So that was it. Thank you for your attention. All of this is done in our usual way as completely open on the Sirius project, both on the Eclipse Git repositories and also now sometimes on the GitHub repository. So feel free to contribute, and we need your feedback to prioritize. There are many possibilities to bring Sirius to the web, many open questions and many passes we could follow. So we really want your feedback on which elements are the most important for you. So don't hesitate to participate to the community, to the Sirius forum. Contact us while you are here at the conference. And we are open for support if you want to help us go quicker, and if you have a concrete need to bring experiments to the production-ready state. If you want to know more, you can follow what happened on Sirius on the Eclipse website here. We have a Twitter account, Eclipse Sirius, with all kinds of news about new releases and important events on the community. And early in the 4th or 5th December, we'll have the next iteration of the SiriusCon conference dedicated to Sirius. This time it will be a live event, so really easy to attend, no need to go to Paris. So please register and participate. And that's all for us. If you have any question, don't hesitate right now or later at the conference. And don't hesitate. Don't remember, sorry, to evaluate the sessions. If you have any questions. No question? Yes?
Yeah.
Is it possible to work at one diagram at the same time from more than one user?
So the question was, is it possible to have multiple users interactive with the same diagram in the web page? And actually, yes, it is. The videos that we've shown today are on my GitHub account, and you could go there, and we have a demo with two editors side by side with user creating new elements on each web browser.
Any other question? No? Nice. Thank you.
Thank you.